So as we talked about the other day, there are some guidelines and some rules for verifying trig identities. First rule, work with one side of the equation at a time. And as I mentioned the other day, it's usually actually going to be easier to work with a more complicated side. It's easier to simplify than it is to expand. Make sure you only ever work with one side of the equation. If you work with one side of the equation and it doesn't work, that's fine to try the other side then, but you're only ever manipulating one side at a time. And when solving identities, you want to look for opportunities to factor, to add fractions and find common denominators, to square a binomial, or to create a monomial denominator. So pretty much any way that you can expand or simplify fractions. Oops. For number 3, you want to look for opportunities to use the fundamental identities. A lot of times, actually, you just putting everything in terms of sine and cosine can lead you down the correct path. So you want to look to see sines and cosines pair up well, secants and tangents, cosecants, cotangents. Once you do a bunch of these, you'll kind of start to see a pattern in some of the rules here. As I mentioned with number 4, if nothing else, put everything in terms of sine and cosine and see if that takes you somewhere. It may not look like it at first, but putting everything in terms of sine and cosine may be really helpful. And my final rule for solving trig identities, you have to try something. I love to work on trig identities. I will help you anytime you have questions, but you have to bring these an attempt. Just trying nothing is not a real attempt. Just put everything in terms of sine and cosine, add fractions, whatever you can do. All right, so our first example here, cosine of x plus sine of x times tangent of x equals secant of x. So it's going to be easier to manipulate the left side of the equal sign here because it's easier to simplify, as I mentioned earlier. All right, so one meant rule, put everything in terms of cosine. But if I had cosine of x plus sine of x as sine of x over cosine of x. And what this gives me is I have cosine of x plus sine squared of x over cosine. So now I have an opportunity to combine and make this one fraction. So my common denominator that I need is going to be cosine of x. So I don't have to do anything to this is sine squared of x. What do I have to do here? Multiply top and bottom by cosine of x, so I get cosine squared of x. My numerator, cosine squared of x plus sine squared of x, is 1. So I have 1 over cosine of x, which equals secant of x, and I'm done, because that's what I was trying to prove. All right. Number 2 here, secant of pi halves minus x over tangent of pi halves minus x equals secant of x. So look at your cofunctionary identities. You have your sheet out. Secant of pi halves minus x is cosecant of x over tangent of pi halves minus x is cotangent of x. So you could also, a side note here, cosecant of x over cotangent of x can be written as this. These are the equivalent statements. They mean the exact same thing. Right? So coming from this cosecant of x, this is cosecant of x times 1 over cotangent of x, which is really cosecant of x times 1 over cotangent of x, just tangent of x. Putting everything in terms of sine and cosine allows me to cancel out the sine of x, and I'm really just left with 1 over cosine of x, which also equals secant of x. So 1 and 2 are two drastically different problems, but they both just simplified to secant of x. Number 3, another drastically different problem, but still just reducing secant of x. So 1 plus cosecant of negative theta. So even and odd identities here. This is 1 cosecant of negative cosecant theta over cosine of negative theta is even, so it's equivalent to cosine of theta. Cotangent of negative theta is negative cotangent of theta. All right, this one is a little trickier. So I'm going to put everything in terms of sine and cosine. So by putting everything in terms of sine and cosine, I have 1 minus 1 over sine of theta divided by cosine of theta minus cosine of theta over sine. I don't like these compound fractions. I don't like having fractions inside of fractions, so I'm going to limit it. So I'm going to multiply top and bottom by sine of theta. I'm allowed to do that because what am I really multiplying by? 1. So what do I have then? Well, distributing. I have sine of theta minus 1, because these sine of theta over sine of theta cosine of theta minus cosine of theta, because your sines. Now, take a look at that denominator. You may notice that it will factor. So my numerator, I have sine of theta minus 1 over, factoring out of cosine of theta, I have sine of theta minus 1. Looking here now, these, what I have in parentheses, cancel. And I'm really just left with 1 over cosine of theta, which, once again, is secant of theta. So 3 very, very drastically different problems, but they all reduce secant of theta. So the thing about trig identities is there is no one set path. You could go about these a variety of ways. The ways I'm doing this is just kind of how my ideas and thoughts flow there, but you could go about this a completely different way, and that's fine. As long as you get to show the one side equals the other, you're perfectly fine. All right, so I'm going to stop the video here. We should be able to finish the last few problems in a minute.